Welcome back to my channel. It's been a minute. I have been traveling, so I haven't had the opportunity to make like a face-to-face video in a minute. So I'm back. First off, I'm having to work with AirPods and no real second monitor in this small little workstation, but I'll try to make a few more vids for you guys. So please like and subscribe if this is your first time seeing my videos, and let me know what you'd like to see in the future videos. Um, I have some more cooking, but I'm always down for some flexibility. Anyways, today, so Heatherwick has been in the news a lot recently, for good or for bad, but today or yesterday, he opened up his new park in New York City, over by the Whitney Museum, the Little Island Park, and I thought it would be a fun exercise to just go through and remake it in Grasshopper and see if I can do it relatively quickly and sketchily, and hopefully you guys would enjoy that sort of thing. So anyways, here are just some pictures. I'm gonna try to break down the logic also of this park. It's pretty simple. Just like a fabrication. I mean, it's beautiful. I really enjoy this park. So what I'm gonna be doing in Rhino, I'm gonna try to break this down in Photoshop for y'all. Let's see if I can. Let's see if my sketching skills are up to par. So I'm simply just gonna have a plane. We're going to start out with a plane, and what is going to happen, I'm going to use sub D in Rhino to like sculpt this plane to be that final shape, but it's going to be pretty simple. What we're going to do is populate it with a lot of points within the plane, and then this is going to be sort of used as the network and where eventually the columns will be. So then I'm going to do is I'm going to use Voronoi, which is sort of like the original Grasshopper trick. What it does is it essentially creates circles at each point and expands them until it intersects another circle. And what you end up getting is this network between each point that always goes through the midpoint of each point. And it will create a sort of series of geometric shapes that will go over the whole thing. Anyways, what I'm going to do then is take these, and I need to establish a rule. So for example, I'm just going to take this guy, let me highlight him here, blue. This one, let's just say I have this polyline in the center, so I'm going to redraw that down here, then. What I'm going to need to do is make this into a series of curves that's going to define that geometry that goes down to the ground, or into the water, I guess, in this scenario. So like this. So this would be the blue line, the top polyline. And then I'm going to end up making a series of these lines, and in different scales. Sorry for my isometric drawing as well. That's going to end up allowing me to create some sort of lofted geometry. And I mean, of course, it's going to be a little bit more complex than that, but that is the gist of what I will be creating today. And then I can apply that same rule to each one of these spots. And then I'm going to have this surface that I can now manipulate and change and create different hierarchies and dimensions in the Z to create like that sculpted landscape. Anyways, okay, let's dive into Rhino. So I am going to first make a sub D surface, and I'm just going to make it a square. I'm not going to be very accurate, as you know. I never am accurate on this. I always just like to play around. Let's zoom in on this guy. Let's move him up a little bit because we're going to need to project this down. And let's just grab a couple of these surfaces and kind of play around and see what happens. I mean, this is like the easiest part. Honestly, I think that's fine. Yeah, this will just be our prototype. We can go back and refine this later. One important thing though is that because we're going to be projecting onto the surface, we need to actually preserve these corners, as you can see in the original Heatherwick. So I'm going to crease those, which is going to allow, so when I click tab and toggle between the smooth mode and the rigid mode, it actually pins those points with a crease. Anyways, okay, let's bring this sub D surface into Grasshopper. And I'm going to need, okay, so now I need to be able to project. So I need to now take this surface and let's just project this. I'm going to need to create my, I'm going to need to do a populate 2D. So I'm going to need to find the 2D version of this thing. So let's just project this down. Project an object onto a plane. I think this should work. Oh, yep, there we are. So that's now the surface that we can project onto. Rectangle that defines. Oh, okay. Wait. So we actually, they don't want a geometry. They want a rectangle, which I think we can get with a bounding box. Now this will output one flat box, which I think will be, yeah, okay, perfect. So now we have this sort of, oh, here, let me turn on bifocals. The app by, I think it's NBBJ, that allows you to display these guys. Okay, anyway, so now we have our sub D, which I'll highlight the input. It's projecting itself down and taking a bounding box. You could also reverse these, it doesn't matter. And now what we're doing is we're populating it. It's set default set for 100 points. So let's lower that for now. Let's go to like, I don't know, 80 or 50 or something. So this is this is controlling the number of points. We can do whatever we want. And we can also create seeds and whatnot to further, play around with the powers of that B with parametric architecture. Anyways, so now that we have the populate 2D, now we can just do a simple Voronoi. Let's do, which one of these? The right one, right over right. Ah, perfect. Now it's going to give us a now it's going to give us the planar, which we can see how that's going to relate. So now what we're going to do is so now what's going to input is a bunch of polylines here. And so now we can just project those polylines, project a curve onto a B-rep, perfect. And we're going to bring back in this, because sub D and B-rep can be interchangeable. This is an interesting part. So sub D and B-rep can be interchangeable, but sub D and surface cannot be interchangeable. So that's not going to work. But as long as you work within B-reps, you don't need to convert this to a NURB surface. And you can't do NURB surface in Grasshopper that I've seen. Let me know, actually, if you can figure out a way. There might be a way of taking this B-rep and then exporting it to a series of surfaces, but I haven't found how to do that. So you'd have to do that in Rhino. Anyway, so we can just take this sub D and link it back to the B-rep to be projected. And now we're starting to get something interesting. So let's hide all these guys. And we now have the basis for what our island is. Although what I'm not liking though is that these are all curves. So it's actually not simple. And what we don't have is the definition to isolate that this is the closed thing. So we need to first off close each one of these polylines, and also I'm gonna rebuild each one of these polylines so it doesn't have this curvature on each one. So we're gonna take the discontinuity of each polyline, which breaks it down into points. And luckily our trees are already built to have one polyline per branch. So we can do this without having to worry about creating, one gigantic polyline. So we're going to take this discontinuity, and we're going to bring in a polyline. And let's just hide this. Hide this. So now you can see that it's going, but we do want to close it. So if you just right click on the C, set Boolean true, this will finalize the polyline. And I am seeing one problem at the corners. Maybe we can fix that later, because it's disregarding that corner piece. But anyways, let's just fix that later. Anyway, so now we have this like network of Voronoi. that is going to be responsive. So if I go back and change that sub D, it will work. But let us now sort of build out. I'm actually just going to take, see if, oh, I need to, let's just do this with a 1. So I'm just going to demonstrate on 1, and then we can go back and like analyze how it's going to work on the rest of them. So what I did is just sort of flatten that whole list so I can just extract the first item to play with, because I just don't want to do each one at the same time. So what we're going to do is 1. So I'm going to take this, and like I drew in Photoshop, I'm going to take a series of, I'm going to take this polyline, and then I'm going to move it down a series of times, and we're going to then loft in between those to create a, each individual sort of like scalloped. So we can take that, we can move, I already know we're going to need to move in V and in the negative. I'm not really playing within scale right now, as you can tell. I'm just kind of wiling it, so I don't even know the, oh, this is in centimeters. So this is going to be wildly out of scale, but we can deal with that. Let's just try 12. It's a solid number to start with. Okay. Actually, and also let's bring in, I'm gonna need to loft these in the end. So actually, let's just bring in a merge and a loft at the end. You can link all of these curves. For example, if I was to take, I could go into here and then hold down shift to add another wire, by the way, and bring this into here, and we could start to see that loft there. But because I know I'm going to need to add in more curves, it'll be nice just to be able to organize and have these always in order before the loft. Yeah, okay. So here we have this. That's looking nice. Let's bring, I know I'm going to need to bring in at least one more. So I'm going to get and I need to scale them down. So I'm going to do another one. Let's just have a scale. We're going to want to bring in this next one, and we're going to scale it. We're going to need sort of a center point within each one of these. So I'm going to get a polygon center. It's going to give you 3 different ones, which is the average, whatever. Have another different average and area centroid. Well, anyways, it doesn't matter. Let's just grab one of these. So there, or this one will give you there. It doesn't matter. I'm just going to go with grab this one. And so that's going to be used as our center of scaling. As you can see, now we have a third point, and this is going to be a percentile with 0.5 obviously being half the scale. Let's just bring it to 0.95 so we have total control. And that's obviously not going to be much, but we can now bring it all the way down. Okay, interesting. This is definitely going to need to be much smaller, and also it's going to need to move down. So I'm just going to do Control V, and copy this, and then move this guy. Oh God. Move this guy. Keep this. I could also make these. So I could take. So now this guy is hide these. Now this is our next curve. I could make this this thing dependent on this one, for example. So I could like link that. So whenever here, oh wait, let's plug this in first. So now I have a third curve. As you can start to see, immediately we're getting a very Heatherwicky style. I don't have the photos up, but a very Heatherwicky style, Heatherwicky style base to begin with, which is nice. And what I was saying before about linking, I can actually, sorry, I probably should have made that bigger. Is I could take this 12. So when I move that 12, I could also move that by 12. So now they're dependent on each other, which sort of like I can move it down, 24, and the other one will also move down by 20. which is actually kind of nice. But for now, while I'm still building it, I'm going to try to keep that this independent. And then we're going to need, now we've done the first curve, the second curve, and now let's see what happens when I bring it to a circle. So I'm going to once again get that polygon center of this guy. I don't like that, and let's make a circle on there, which I think we can just do the CNR. Put this guy there. Obviously, it's going to start out with a Z normal, which is great, and then a 5. Let's just bring in, 5 or something. See how big that is. That's going to be, I think, yeah, 3. 3 looks pretty good. And then what we're going to do is bring that in. Oh, and we need to definitely move that down again. So let's copy this again. Steal this guy again. Move there. Then replace that last circle with that. And that's actually looking pretty good. Maybe we can move that like down there. Yeah, that is pretty nice. This original circle. So now we can just see the ones, the curves that sort of are forming our extrusion. So these 4 curves are those guys. And then I'm just gonna move this. I'm gonna copy this the way. Where is this? Let me bring up those pictures again. As you can see here, there's sort of this bulbous effect that goes down to this point, and then this point is a straight. So I don't want to bring that next circle into the loft because it'll distort the whole thing. I just want to now extrude this down to the 0. So I'm going to, which will mean it will not connect into the loft. So I'm going to create, what do I need to do? I need to have a direction. Actually, I'm just going to create so I'm going to take this last, so now I have this last guy in this last circle be moved down to, let's construct a plane, because each one of these will need to go down to the same exact point. So let's just construct a point. And let's just say it's at, oh God, wait. Oh, actually, we can just move. So we can delete that. Move in here. So this is going to move it to the plane, but we can also just negative. And then go to like again 12. Seems to have a fascination with 12 being. So this is this global point that these are all going to go down to, and I can change. So now I can change this at the end, because what we're going to do now is we're going to get another loft. We can just do this because it's only going to be 2 of them. Anyways, okay, so great. Now we have these 2 lofts. I'm just going to bring them back together in a final piece that I can preview at the end. Okay, so what we've done is we actually have a pretty decent interpretation. I think it could use some work refining, this guy. I think this guy is sort of, this bulb out is pretty weird. Or maybe this one just needs to be scaled a little bit. It can't just be moved down. Or it's perhaps like a loft option. For example, here, maybe I don't want to do normal. I'm going to want to do loose. Let's see what happens. Loose. Yeah, it's kind of ugly. Let's do tight. You know what? I think it's fine. I think it's fine. Okay, so now what we have is we have sort of, okay, I mean it's looking pretty nice. We're gonna need to, one thing I want to do first off is I know that these curves have a fillet on them. They're not actually uh they're not actually perfectly straight. They're slightly filleted. As you can see, sort of you see these have these little fillets. So I am going to take a few of these curves and bring them into a fillet. And I think it's going to be, let's just try 5 for the radius. And so this, let's just try with this curve. Okay, I mean, that's not bad. Give it a really gentle. So what I'm going to do is actually, the only way I don't want to fillet, I'm going to copy this merge. This is kind of a weird way to use merge, but the thing is I don't want to fillet. I don't want to use that same, I don't want to copy. I could copy, so what I could do is copy this fillet and just bring in all 3 of those different wires. But instead I'm going to do is just nix out the circle, because I'm not going to fillet, obviously, the circle. So I'm going to bring all of these guys into here. Now we're going to have each one of those, and then I'm going to just go in here, replace that, and then delete. So now I have those 3 filleted curves and bringing in the circle at the end before you loft it. And then the second loft, and then the merge. Okay, so let's see what actually happens. Let's see what actually happens when I replace this. So what I'm going to do is, this spot needs to be gone because I'm just going to, okay, so Control Shift and just plug all of these guys into here. Now let's see. All right, well, that looks pretty damn good. Actually worked out very well. Oh, there's some weird twisting going on, which is working. Oh, it's the loft. There's always issues with the loft. Let's see if I can just quickly sort that out with is there, I think there's a line at called the start point. You do Control Alt. I just gotta find the Control Alt. So it's in the vector or a long curve. I think it's gonna be pointing to. Is it with a seam? There's a seam of a closed curve. Seam, or corner. Align curve seams. Align curve option. Derivatively. Okay, so I think this will be it. What I'm gonna do is I'm just gonna push all of these through this way, resulting curves. I don't know why it's called A or aligned. And I think that's wait, let's custom preview. Much easier to see when you actually have some. Oh boy, that's kind of messed up. What is going on here? Ooh, that is wild. I like that. Is it because of the loft options I've done? Or is it, wait, let's see without how aligning goes. Okay, that looks way better actually. It's just about how it intersects with the circle at the bottom. It's almost like it needs to. Oh yeah, I can see it right there. Like these ones are terrible. If I bring in this aligned curve, what would it do there? Ooh, yeah, that's not nice. Where's the other one of these? Full shift line curve scene. Oh, this is in oh god, where was that? Oh, alt to see where it's pointing out. Oh, that took me a second. Curve. Oh, that's what we have. So we just need the other one. This one. Curve. Oh, I'm gonna need to build a curve now. Yeah, I didn't want to do this. Actually, before we have to dive into figuring one of these out, let us just try to use loft options for all this. Okay, so that sort of does the curve line scene, which is not very nice. Then it could be like, for example, that if I just do loose, ooh, you know what? I think this is good. I mean, this worked out. It's just I think we need to bring in. So ignore these. I think that's just going to be a path down the wrong track. I think we can just use loft in this, but what we need to do is also bring in one more of these. So what I'm going to do is just take this guy and then jam another thing in here, which will take this and also give another one that's just been moved down just an absolute hint. So we have this, that into here. We're just going to move this down 1 or 2. Let's try it. This guy into there. Because I think what we're missing is sort of this this kind of rounding back. Yeah, I mean this looks so much better. Let's keep it at 10 or something. And then this, so wait, now this one's the one that needs to move to the plane. I actually don't think it matters so much. But oh, see, this is exactly why I bring the merge before the loft, which I cheated here, because now I need to bring this back and then also need to bring this back. And this is just making the leg. But you can see sometimes it's not even present because they're so low. Okay, so what we have here is a pretty decent version of the Heatherwick thing. I don't think I'm going to go. I don't really want to go into like creating the corners. That's just going to be sort of more work along the same path. But what I do want to show you is sort of like now the flexibility of this. For example, I can, and this is like definitely me hyping on how nice sub D is in Rhino 7, which I like cannot get over. But I can make like minor. Oh shit, interesting. Why did that not work? No profile curve is removed. Solution must be non-negative unless it's the size of the collection. And that work. Okay, well, as I hate that as I say, you know, like how flexible it is, it immediately breaks, which is like classic Grasshopper. But I just wait. I want to. If I is it because I move it out of the bounding box? No, I think it was just basically an anomaly. Or I mean, let's push it. Let's really see what. Yeah, that's not. It's not liking that. I wonder if it's because of the fillet. Get rid of the fillet. No, fillet doesn't matter in there. Interesting. So I mean, it's like making some, but then not others. Crazy. Okay. Well, let's try to keep it. Luckily, Heatherwicks is a square. Maybe that's why. Maybe he didn't. Maybe he learned his lesson trying to pull those points away, and for some reason he started getting wild answers. Anyways, but I mean, like the beauty of this is sort of course, you know, the parametric. So 50 points, but actually, you know what? For 100, probably gonna break right now just because you know that's how it would be. But I mean, there you are. This is let's just bake this. You know, I always like to you know review what you're making. So let's go. Let's see it in Arctic mode. What is this looking? I mean, this is looking fantastic actually. I'm surprised at how nicely that turned out. Of course, I'm not going to be here to be the one to teach you how to do the landscape. That's basically just going to be a whole work on its own of defining, you know, the edges and bringing that up and creating the surface. Although we actually have the surface here. Over. So I mean, that's the work of the landscape architect. Here we are, just trying to you know play around with a little bit of computation and yeah, make some interesting sketches. I basically just enjoy doing these things. That's why I do them. Anyways, I think that's gonna be it for the video. That was hopefully quick. I don't believe that was quick. I believe that was a long one. But I'm glad to be back and like narrating some videos. I think they're fun to make. Anyways, let me know. Like, please leave a like on the video. I'm trying to you know build out the subscriber base and be able to show more people what I do. And I mean I spend a lot of time on this, so it'd be nice to always appreciate you know the feedback and whatnot. Yeah, have a good one. Thanks.